In today's tutorial we will discuss the question how we could best polymerize this monomer. First idea often is, let's take a radical polymerization. However, it is not the easiest way to polymerize it, because for a radical polymerization you need a starter molecule which either by irradiation or by heating up produces the starting radicals. In this case it's better to choose the anionic polymerization, since this molecule is highly electron demanding. We have, because of mesomeric interaction, a clear delta plus here, and nucleophiles best with an anionic charge will react to give an anion like this, which is mesomerically stabilized to both sides, to the ester group and to the cyano group. With the next molecule of the monomer, again at this position the CC bond formation will take place, and it will result in an elongation of the chain Let's abbreviate the ester functionality just by an E. And again, we have a mesomerically stabilized anion. Finally, this polymerization might be stopped by protonation. And we could then have a polymer if we say we have N molecules of this, then we can symbolize that we have a chain with N minus 1 moieties of this plus the additional here. So overall, all of these monomers might be incorporated in such a polymer. While in reality, you will have a couple of polymer chains, of course. So the simplest nucleophile in this case is just an hydroxyl anion. And where do you get the hydroxyl anion from? The most moisture in the air is just sufficient. In that case, we have the equilibrium of the water dissociation and this very low concentration of the hydroxyl anion is sufficient to initiate the polymerization of these cyanoacrylates. And now we also know where does the proton come from? Well, from the H3O+. Thanks for listening.